afternoon, everyone. This is Jean-Daniel Ossel from the Java Card Forum, and it's my pleasure to welcome you to this fifth webinar of our 2025 webinar series. Our guest today is Amedeo Veneroso, Chair of the Trusted Connectivity Alliance, Interoperability Working Group, and Mobile Core Team Leader at STMircoelectronics. Which Microelectronics, by the way, is a founding member company of the Java Card Forum. Amedeo is a senior technical project manager and team leader, proficient in cryptography and embedded system technology, with more than 20 years experience in secure element and smart cards. He's a manager in STMircoelectronics for product development in telecom and mobile devices, from embedded SIM to secure element. Since 2007, Amedeo is the chairman of the Trusted Connectivity Alliance Interoperability Working Group, focused on increasing interoperability among SIM and secure element stakeholders. Embedded SIM are mainstream in smartphones nowadays and can host multiple operator profiles from different mobile network operators. Those profiles can host Java Card Applet too. Amedeo will present the guidelines and loader tool developed by the TCA to ensure Java Card Applet embedded in operator profiles are not affecting the resilience and security of its SIM deployment. We will also learn how security can be bolstered by the TCALoader tool, as well as the latest enhancements to the TCA Interoperable Profile Package technical specification. We will open the microphone for questions at the end of the presentation. They will be muted during the presentation. And if you prefer, you will be able, during the presentation, to post questions into the chat window, and we will go to the question of the chat window after the presentation. Now, Amedeo, without waiting further, the floor is yours.
Thank you, Jean-Daniel, and thank you all for participating to this webinar. It's really a pleasure to be here again. I already participated to one similar webinar last year on the Java Card Forum, so thank you for inviting me again. I believe you found interesting the one of last year, and I hope you will find also the one of this year interesting and useful for your activities. So today we will dive into the security and interoperability of Java Card Applet and on the contribution that TCA has done in the last year in order to support the developer community and all the embedded SIM and SIM stakeholders to leverage on a more secure, interoperable, and safe solution driven by the industry. So my name is Amedeo Veneroso. Thank you, Jean-Daniel, for the introduction. I have been leading the Interoperability Working Group of TCA for many years, so I can contribute to this webinar with a long experience in terms of interoperability and in terms of experience on the field. And I've been leading the software development of embedded SIM and SIM product at STMircoelectronics in our embedded SIM secure elements for more than 20 years. So I hope you will find my experience useful for your activities and for your implementation of solutions. So I'm here to represent the Trusted Connectivity Alliance. Trusted Connectivity Alliance, I believe you know it, but just in case, is a global industry association working to enable trust in a connected future. Our vision is to drive the sustained growth of a connected society through trusted connectivity which protects assets and user privacy and networks. And we do that with main, let's say, deliverables and activities that fall in four main pillars. One is market monitoring. So we have an active look on the market, where it's going, especially, of course, connected to the security of the devices that we are doing and their penetration and provision inside the solutions and the industry. And we will see we are also quite authoritative in the communicating about the market trends. We develop specifications and interoperability. So we know that secure solutions needs to be very well specified, so with clear interfaces and so on, and needs to work without specific issues with between with other devices. So interoperability is really a paragon of our technology. We have done many activities in the last years. I will explain a little bit better later. Of course, the interoperability documents that are a little bit at the center of this webinar, but also other tests, the documentation, specifications, and tools to help developers. We work as an industry association, so we liaise with other similar associations and entities to have a uniform and coherent industry engagement and strategy. And of course, we provide education events in order to support the knowledge and awareness of our technologies, such as this webinar. This is the list of our members. I mean, we have several levels of membership. Executives are members are GND, IDEMIA, NXP, ST, Thales, and Valid, and I work in ST since more than 20 years. We have full members that are card-centric, Eastcom, Peace, Linxens, and Trasna. eSIM that are Kigen, Monty Mobile, and Red T Mobile, and ordinary member as Compion. And in case you are interested in knowing more about the membership or how to join our association, do not hesitate to contact us. Why TCA is relevant when when we talk about interoperability of secure element solution, and in particular of eSIM? I think that this number says it all. So we represent around 98% of the global eSIM hardware market, meaning that over 100 embedded SIM that are developed and deployed in the field, in your mobile phone or your home appliance or smart meter or whatever, 98 of them, over 100, are produced by one of the TCA members. So we really represent the industry that is empowering the entire ecosystem with the eSIM technology, in particular from the, let's say, from the device point of view. And for this reason, we can say that we are the only organization that can offer a quantitative global view of embedded SIM market shipments, and we both for what we have seen today, so our actual data, but also from what our strategy and forecast data tends to. And of course, the intelligence that we can provide on the embedded SIM is, to be surely considered as very well authoritative and worth of trust, as again, we are representing almost, let's say, the entire eSIM business. And it's not a trivial business. It's already a very important market that is growing year over year. So consider that only in last year, we increased of the 35% the number of embedded SIM hardware that were deployed over the field. So we surpassed the 500 million units produced by TCA, over 514 produced worldwide. Of course, this is an estimation for 514, while 503 is a measured number because it's a number from TCA members. And what is even more important and interesting for me is the fact that not only it's increasing the number of embedded SIM that are deployed on the market, but they are used more. So, as you know, the embedded SIM is a soldered chip that is fitting in your mobile phone or any other appliance, able to download a telecom profile, what is called a soft profile or telecom profile, to switch from one telecom operator to another. Well, what it happened in the last year is that the number of such operations, so downloading a different telecom operator profile to switch from one profile to another or to enable the usage simply of the embedded SIM, is increased of 56%, so more than 35%. It means that not only we had more embedded SIM devices on the market, but they were used even more in percentage compared to the previous year. And of course, I mean, again, we are very, very aware of what is happening in the eSIM industry, as we are the eSIM industry, basically. So we can highlight why we had this positive trend and why we believe that this trend will can only go better, no, can only improve. Because the major, let's say, trends were for sure impacted and, let's say, influenced by the improving of the economic conditions. Because, of course, this increased the number of smartphones that were worldwide sold, and of course, with in particular related to high-end and mid-range devices that are the ones that typically embed, consider, let's say, embedded SIM. Of course, not all the mobile phone yet implements the embedded SIM hardware, but I mean, it's also increasing the range of devices doing that. So in the past, it was really high-end phones, and now also mid-range devices leverage on this technology. And I mean, the first success of the solution at the end was in North America, and North America is continuing in leading this success, especially in the consumer space. In fact, in North America, we see that many devices, many mobile phone models are eSIM only, meaning that while in the past, and I mean, in Europe, it's still quite the trend, and from what I see, you have the embedded SIM inside the mobile phone, but you have also a SIM tray, so a traditional SIM slot in which you can insert a removable SIM, and this SIM tray can be used to put a removable SIM, but you have also the eSIM hardware. Well, what is happening in North America is that several models are now supporting only the embedded SIM solution, and so you are somehow driven to use the eSIM soft profile instead of a removable SIM. In Asia, the profile download operations more than doubled. So also in Asia, it was starting, let's say, the technology to take off, and Europe also had a relevant growth. And in general, also the technology is becoming more and more aware to users, and that are understanding the value and the convenience of it. And telecom operators are also providing their infrastructure, so subscription managers are the services that telecom operators basically manage in order to download the profiles on the embedded SIM. So when a user connects to a telecom portal to download an eSIM profile, at the end it connects to a subscription manager, and the number of such platforms, such backend systems, is increased by around 18%. This is in the consumer. IoT is expected to really explode in the next years. So in the last year, we saw that several companies, especially from TCA, have certified the first solution of products according to the new GSMA standard called SGP32 that defines a new way of managing for the IoT, pushing, let's say, the embedded SIM not only to consumer device, not only to M2M like automotive, cars, and so on, but also to IoT devices that, as you can imagine, can be a penetration of numbers that go even beyond the numbers of the consumer devices. Okay, this is, an increase, excellent success, outstanding success, and so on. But we also need to be careful about security. So what is happening is that, the increase of industry demand for embedded SIM brought also an additional positive effect that the industry players are asking for additional services using the embedded SIM as a secure element. So having a secure element soldered inside the mobile phone has led the possibility of using this secure element also for additional secure services that can be payments, transport ticketing, identity management, secure IoT services, and so on, provided by several service providers. But the point of having so many services and so many applications on the secure element can cause a problem of security. So of course those applications can leverage on the huge security and excellent security model of the Java Card platform, but we know that in order to maintain the highest level of security, it is important that applets respect specific rules, are correctly developed according to specific rules that guarantee the security of the applet, but also guarantee that the applet does not affect the security of the entire device. And this was pretty relevant in case of removable SIM, but it's even more relevant in case of the embedded SIM, for the simple reason that the traditional SIM, so the removable SIM, was at the end issued by a single telecom operator that was the risk owner of the entire solution and was able to control the entire solution, including the applications that were deployed inside the SIM itself. Now, with the embedded SIM, you have multiple telecom operators and service providers that share the same hardware device. And of course, the definition of security architecture and providing of boundary between applications and so on has to guarantee that the sharing of resources of the SIM and the capabilities of application do not harm the entire system, so that you don't harm also applications from other telecom operators. And this in particular needs to avoid that if one applet is vulnerable to malicious software, we need to avoid that the security of the entire device is compromised. This requires a global investment and a global attention from the entire industry. In particular, all the industry organizations and technologies are, of course, caring about maintaining a huge security of the ecosystem, and among them, of course, GSMA that has been driving the standardization of the embedded SIM is in front line to ensure the security of the ecosystem and of the applications. And that's why it was specific focus happened this year as part of the GSMA Coordinated Vulnerabilities Closure, or CVD program, when security researchers highlighted a specific issue impacting eSIM technologies. This attack described how applications loaded through the remote applet management protocols that you should know are protocols that allow the downloading of Java Card applications on eSIM and on SIM and eSIM. This usage of remote application management in case of known keys, like in case of test profiles, can be used or misused to install malicious Java Card application within a profile in an embedded ACC that supports Java Card technology that is quite common as a support. Of course, this was reported as a potential attack with some some consequences, and the TCA, representing the organization of the embedded SEC manufacturer, made its due diligence in order to identify if there was any consequence on our eSIM, and we concluded that no direct consequences on the attack have been identified for most eSIM on the market. Anyway, we considered important also for future attack and future use cases to prevent and to avoid the support of downloading of malicious Java Card applications. So this is something that happened this year. So it was in Q1, Q2 in the first half of the year. And of course, to that, the entire industry reacted. And the reaction, let's say, was coordinated by GSMA that published an application note in June to prevent the misuse of embedded SEC profile and installation of a Java Card application. Other actions, including the update of the eSIM specifications and other documents related to GSMA, are in progress. So I would say at a very good stage. And in the longer term, of course, the industry is always working to raise the security and be sure that all the doors are closed to potential attack, to further advance the security of the embedded SIM. So to summarize, the security of the embedded SIM is always, the industry is always working to improve the security of the embedded SIM, even if it reaches already an amazing level that is among the highest in the world. With the CVD attack, that was how it is known, we GSMA reacted together with the industry with an application note. And what is important is that this application note identifiers among the recommendations that the Java Card application developers should comply with the TCA Trusted Connectivity Alliance stepping stones for Java Card Applet Developers recommendation. This document is a document that is edited by the Interoperability Working Group that I've been chairing for many years, and it's the document that we already presented last year. So in a similar webinar of last year at the Java Card Forum. So in case I will provide you some information about this document today, especially on the security. In case you have other questions or you're interested, you can go to the recording of the last year to gather even more information. So why this document has been mentioned as, let's say, a countermeasure to avoid attacks like the attack that I mentioned, so the CVD attack. It is a checklist for secure applet development. Let's go a little bit more in details. So what are the stepping stones for Java Card Applet developers? So the stepping stones is a brand of documents that we started in 2003. So it's very old, but it is successful. And you can find on the TCA website several editions of those documents. Some are deprecated, so we remove it, but most are still valid. Because over the years, TCA Interoperability Working Group has worked to increase interoperability of the SIM, eSIM, and mobile secure element solutions versus the ecosystem. So in a broad ecosystem in which, of course, interoperability can be an issue for several technologies. So we did several documents and several interoperability analysis for multiple SIM related technologies like Java Card. Of course, the first stepping stones in 2003 were actually on Java Card. And then we continued with the NFC, Smart Card Web Server, Mobile Connect, all technologies that are, of course, relevant for the embedded SIM, but also require some, let's say, attention for interoperability. In 2024, we went back to Java Card. Why? Because, as I said, with the complexity of interoperability of the embedded SIM, we thought it was good to reconsider the Java Card technology to increase in the embedded SIM context, to increase its interoperability of applications. And inside the document, you will find an analysis of key recent Java Card technology updates. So, of course, Java Card 3.1, Java Card 3.2 are explained in the way that, let's say, which is their impact on the telecom products and how telecom application developers should leverage in order to guarantee maximum interoperability. Guidance on the impact on broader ecosystem deployments from 3GPP, ETSI, and GSMA, best practices and security recommendations, and today we will focus on those security recommendations, and an interoperability checklist to help address common challenges and deliver high-quality applets. Why we went back to Java Card? Because we saw a transition. So again, from eSIM to eSIM, the market and the landscape evolved a bit. In fact, you might know that in our context of eSIM, it's very important the concept of product security certification. So security certifications that are typically provided by organizations that follow the common criteria methodology, or that have methodologies that are at the end based on the common criteria. So the common criteria certification provided by several governments are of course, the first example, but also the GSMA, Embedded SEC Security Assurance, is based on the common criteria methodology. Now, in all those common criteria-based certifications, typically the certification results in a series of security guidelines called, in the common criteria slang, operational procedure for the application developer. And application developer should know which are those rules that the application, so the applet, the Java Card Applet, should follow in order to fully leverage on the security mechanisms that are inside the product on which the application is loaded. At the time of the SIM products, this was, let's say, somehow easy. So at that time, I would have called it easy, but compared to today, it was easier for sure, because when an application developer could know on which SIM its applet will be developed. If I develop a secure applet for a specific telecom operator, I can work with the telecom operator to understand the security guidelines of the SIM card that the telecom operator is providing on the market. In the eSIM technology, it's more complex because in the same example, I develop an applet, I give it to a telecom operator. The telecom operator embeds it in a telecom profile, in a soft profile. Then it is downloaded when the user selects that specific telecom operator on an embedded SIM. And when I develop the applet, I don't know on which embedded SIM it will be ultimately downloaded. So even if those embedded SIM comes with some operational procedure, it's almost impossible to understand and to derive all of them. So TCA, with the stepping stones, have made the effort of collecting the majority of security recommendations from the various guidelines, so all the operational procedure, trying to harmonize them in a common set. The first rule that we will present is the bytecode verification. So, of course, in the Java Card forum, you know much better than me what is the bytecode verification and why it is important for the industry. It is the rule number one. Not only for TCA that already devoted some important part on it, but also for GSMA. When pointed to the TCA stepping stones in the application note preventing the misuse of an embedded SEC profile, so the answer to the CVD, highlighted that the most important recommendation was the bytecode verification. What is the off-card bytecode verification? So, particular, when you develop a Java Card Applet, you start from a Java code, then you compile and convert, and then the bytecode verifier controls, so performance analysis, static on the Java Card bytecode, so the intermediate language obtained by this process, to ensure that it has not been manipulated, it adheres to strict rules of Java language, the JCVM specification, and so on. So type safety, memory access restriction, a correct API invocations and boxing are all controlled by this bytecode verifier that completes the security of the virtual machine of our products that are deployed on the field. How you execute it. So in order to execute, to verify if a CAP file that contains the Java Card Applet is consistent and compliant with the rules of the bytecode verifier, of the off-card bytecode verifier, you need to access to the CAP file together with its export file and with all the export file of important packages. Now, a small but important point is that the CAP file, in order to perform all those verifications, to control that the objects that you are using as parameters are in line with the type that have been declared, that the references are not forged to go into specific malicious behavior and so on, you need several components inside the CAP file to be present, including one important one called the descriptor. And the descriptor component is optional because contains actual information just to describe and so to map the CAP file to the rest of the product. But on the smart card, it's not used. So the SIM, the embedded SIM, or any other Java card platform simply does not use it. So it is optional. It's also typically not very small, so it is typically removed. And a demonstration of that is the fact that typically one popular format of applet exchange between developers and profile maker is the interoperable Java card format, the IJC format. So this is a file specified actually many years ago that is very popular. So it's very used by application developers to give the file, the package file to the profile makers. It's optimized, but in its optimizations, it removes the descriptor. So it's not possible to execute the off-card bytecode verifier on the IJC format because it does not contain the descriptor. And so the procedure that is advised in the stepping stones and in general by TCA is that the developer executes the BCV, so the bytecode verifiers, on the CAP file with all the other export files and so on, all the preconditions. The bytecode verifiers also provides you some hash of the components. The algorithm is SHA-256. And so this list of hash is communicated to the profile maker, including, of course, information that the BCV was successful, and the profile maker can verify on the IJC that the hash are the same in order to trace back to the verification as that. So it's a way to at least attest that the developer has executed the bytecode verifier, and you have an evidence that this process was correctly followed. It's not the only rule to be followed to develop the applications. It's not the only rule of our security checklist. Now we will go a little bit faster through the other rules that are, of course, very interesting. I will not be, present an exhaustive list. So, but the document, Java Card Stepping Stones for Interoperability is available, is freely available on TCA website. So in case you find those rules interesting, or in general the context of document interesting, do not hesitate to download it. So other rules, Java Card Applet AID. So there are rules to assign AID to your packages and applications. In particular, the applet developer shall use a registered identifier. This is the first part of ID, registered at ISO and defined in an ISO standard 7816-5. You use the standard API as much as you can. So if they're present, like USCC API, eSIM API, but of course also Java Card and Global Platform standard APIs. And do not use Java Card RMI because, okay, it's also not typically not supported by several implementation because it lacks some security related features. So we typically discourage our developers to use it. For sensitive applet, sensitive data management. So sensitive applets, I mean, so far we have seen rules that almost that all the applications should follow in order to be sure to coexist in a secure way with the other applications. If your application on the other side needs something more, needs to protect its own data, and this is typically the case for an application loaded in a secure element, otherwise which is the value. For sensitive application, we put some rules about sensitive data management, such as the initialization at the beginning and the clear at the end of the session of such data. So you are sure that those data are valid only when you are using it. In case someone is able to access to the buffer of the application while doing very smart attacks through malicious or whatever, at the end, if you have already cleared those data, you are good. And in this clear is also suggested to be done by overwriting with random numbers for non-volatile memory data, or to put those data in transient memory, so for volatile, so card reset would fully, let's say, erase this data, so automatically with the system. When you use constant, if they are sensitive, do not use trivial values like 0 or FF because they are too easy or better, easier to manipulate a memory cell to reach such a values 0, 0 or FF than values that are more complex like A5 or other things. And in particular, if you have multiple values, try to keep an adequate distance in terms of different bit between one and the other, the so-called Hamming distance. And sensitive data must be protected against rollback attacks. In particular, if you use transactions, so if you do several operations and at the end either you have done all of them or none of them, you can do that, but be aware that in case this transaction is rollback, you could somehow roll back also some sensitive data content. The typical, let's say, educational example is you verify a PIN, you understand that the PIN value is wrong, so you decrease the counter of allowed attempts for that specific PIN. If you do that in a transaction and you interrupt the transaction before it is completed, you roll back to the previous value of the counters of the PIN, and so at the end you avoid the countermeasure of decreasing the PIN value. It's I mean, a simple example, but gives you the hint behind the kind of protected against perturbation, and it's protected to control the flow control at application, let's say, at virtual machine level. Nevertheless, for very sensitive applications and very critical flow, it's relevant to consider adding a flow countermeasures also at application level to detect any change on the normal execution flow. So just the typical attack that is done here is that the application flow follows a specific application flow, and by using some special techniques, you are able to alter, and so to bypass some countermeasure, to bypass some verification, to put the application in a wrong state, and so on. It's good to use appropriate measures to verify if you are in those kind of situation, and to detect which actions you should follow, like blocking the application, reset the product, and so on. There are sensitive standard APIs that Java Card Forum defined. In Java Card 3.05 have been defined, like the sensitive result. This can be used for when invoked such sensitive API to be sure that the flow has not been altered by the application execution. So use them. For random, there are some algorithms that have been deprecated, and others that are different usage, like key generation or TRNG should be used for specific cases. Of course, key generation is to generate keys. So those algorithms are implemented by our virtual machines with proper attention and all, let's say, the verification on the security. So it's not by chance that we deprecated some, and we enforce the usage of others in order to reach the security. Avoid the use of programmatic exceptions. So what are programmatic exceptions? Are exceptions that you expect to be reached as part of your normal behavior of the application, like you, instead of doing for to loop in an array, you just access to the array one byte after the other until you reach the index out of bound exception. This is not efficient because the overhead of the exception management is not trivial, but in particular is not safe because you need to be sure that the exceptions are really symptoms of some bad operation happening, in order that your application can reach full management and full control of those erroneous situations. And in order to make it more convenient, we collected these and all the others. So you see there are more than 30 checks in a checklist. So did you verify that your application has used the sensitive result? Did you verify that key generation and TRNG algorithm has been used to random, and so on? This checklist for us, it's useful for application developers that can verify if they checked all the controls before while developing the application, for quality and test engineers to verify proper implementation, and for customers, because when you are purchasing an applet from a third party, you can use this checklist to get an assurance that those programming principles were taken into account. That's it for the stepping stones. Just very quickly, small comment on the TCALoader. This is a tool that we offer for free from our website, so you can download from the TCA website for free to download applications on the secure elements and on your products, of course. And this is very useful in order to test interoperability across different deployments. Of course, before loading application, bytecode verification should be performed off card. And another important milestone for the interoperability and for the specification of the embedded SIM is the interoperable profile package specification. That is the common specification used by all the embedded SIM in the world. That is the specification how you let's say, you produce and interpret a eSIM soft profile containing a telecom subscription, and it has already been very successful since the very beginning of the embedded SIM technology. Latest versions also includes updates and clarifications to promote security, interoperability, and to support 5G and network-constrained IoT devices. Okay, that's it. Of course, I mean, with the TCA stepping stones and in general with the industry activities, the entire industry is always working on the increase of the applet security as an important fundamental aspect of our technology. In order to increase your applet solutions, you should comply with the security recommendation within the stepping stones as I presented, and consider also GSMA recommendation about that. This is not the end of the story for improved security. We know it's a journey. It's not that we have reached our goal and we completed. So for sure, we will continue to work collaboratively across the industry to maximize the security interoperability, and also in the Interoperable working group. We are already working for the next generation of interoperability for the embedded SIM technology. Okay, that's it. I really thank you for being still here. And of course, I'm really happy to get your questions.
Thank you very much, Amedeo, for this presentation. We can now open the microphone if you have a question that you would like to ask directly to Amedeo. And
hello.
Yes, please.
Hello, good morning. Thank you very much for the webinar. I say that the webinar including market information and also the technical part. So I have two kinds of questions. First, I say that there is a figure about market increase. I remember the shipment volumes. It was 35% increase, right? It's including consumer and IoT together.
Yes, the first answer is yes, and you can get more details from the market analysis that can be downloaded from TCA website.
Okay, got it. Thank you. Second, it is about technical question. I have two technical questions to ask your suggestion. First, you mentioned that there are many applications, for example, payment, may have the possibility to be included in the eSIM. Do you have any suggestion about the architecture to protect the security?
Yes, actually, the stepping stones is full of those suggestions to, let's say, to design your application around the security, and in order to have it, of course, if you develop an application of secure services for a specific vertical, for a specific implementation model, you also need to take into account rules and recommendations and regulations from that specific business. So you mentioned the payment application. For that, for sure, I would start from EMV specifications in order to start, with that. But in the Java Card stepping stones, you will find the general rules that apply also to payment applications.
Okay, thank you. I think you also heard that maybe Strongbox will be mandatory for eSIM for UASCC also. So do you have any suggestion?
Okay, so I believe by Strongbox you mentioned it's relate to a technology from Google, right? So the secure element application from Google. So for that, I really advise you to verify with the compliance device documentation from Google, the CDD, where you can find information around that. From what I know, the most recent CDD does not fully mandate a Strongbox for all the devices, but of course, we we are all seeing a general trend of security evolution for the devices in the mobile and in all other segments. So I cannot comment if it will become mandatory or if become optional, but for sure the value of the secure element of security and of applications like the Strongbox ecosystem that Google is providing in the eSIM world and the secure element world is providing more and more advantages. So mandatory, it's something that you should ask to Google, but the value, I believe it will drive more and more and more deployments on this technology.
Yes, from technical side, do you think this application can coexist with MO profiles together in eSIM?
If you look at the requirements of an application like the KeyMint that is at the heart of the Strongbox, the basic requirements coming from the KeyMint are in line with the technology that are offered by secure elements, including embedded SIM. So I would say yes, it can be compatible.
Okay, got it. Thank you. I have a last question. I'm sorry. I always confusing about the interoperability profile for consumer and IoT, because I understand that maybe for these two architecture, the profile maybe will follow the same TCA profile specification, right? I'm just wondering for IoT, the hardware resources are limited, but for consumer, it's a rich environment. I'm thinking for IoT, do you consider to reduce or optimize the profile architecture to make it less or consume less resources, or it will be the same?
Okay, so I'm sorry I lost the connection for a while, but I understood the question. So
okay. Let me repeat. The question is.
I got the question. I got the question between the consumer and the IoT. So the format of the two profiles are the same specification. So if you go to the interoperable profile specification, it applies to both the consumer and IoT devices. Okay. Of course, we expect that the content of the two profiles are different because applications, especially Java Card Applet in consumer, may be very different from in terms of their content and so on, may be different from application in the IoT. In addition, for the IoT, it has been defined the concept of a minimal profile that is an extension of the IoT of the profile specification that can be used to really squeeze the size of the profile without, let's say, you don't have so many services, but at the end you have a profile that is very small. Even if this was introduced for the IoT, it does not prevent the adoption also in consumer devices, and it will be embedded SIM provider, OEM providers, and telecom operator providers with the DSM-DP+ to decide whether you will want to use a minimal profile approach also for the consumer products or not.
I can understand the intention, but we to be honest, we have the difficulties. For example, to define a product, whether for IoT we can use the smaller flash. For example, I think we have to do the interoperability testing for IoT also, right? Not only consumer. For IoT devices, for IoT eSIM, we also need to do the eSIM profile testing globally. Then we are afraid. We are afraid of the flash memory.
Sure. No. Of course, interoperability is complicated. Interoperability in the IoT, maybe it's even more complicated than in consumer, for the simple reason that IoT is, the definition is much wider than the definition in consumer. So you have IoT devices that can be very small in terms of memory, of performances, and so on, with network constraints and so on. And you can have IoT devices that maybe are even more powerful than mobile phones. Of course, it's the definition is much wider, and I agree with you that interoperability will be even more a challenge. The good thing is that the industry is mature, so I mean, we leverage on more than 20 years of interoperability of SIM solutions, and we are coming from already several years of successful embedded SIM deployments for consumer. We don't throw away this experience. Of course, we will have some additional challenges with the IoT for the fact that are unattended devices and so on. But again, in the Java Card interoperability stepping stones, you will have some rules also to improve the interoperability of IoT applications. You mentioned the flash memory. We have inside the document rules to extend the lifetime of the flash, or at least to avoid that it is compromised by the misusage of the Java Card application.
So in short term, there's no possibility to for the interoperability to be easy, right? Right.
It's always a journey, as I said before.
Yeah. I fully agree. It's a pleasure to talking with you. Thank you so much. Have a good day.
Thank you for this interesting question. I have a comment on what was said. The question before, on applications such as the Strongbox. I think what you presented, Amedeo, is related to MNO profile and the guideline, the stepping stone for the applet in the MNO profile. And there are other technologies. Strongbox was mentioned where they would use the SIM, but in a security domain, related to the MNO profile, because it has to be for the full phone. And there's also this new technology of global platform, the SAM, and GSMA requirement, where in fact you can also have security domain on the side of the MNO profile. So the question is, do you plan to extend these stepping stones to applets that would not be in MNO profile, but that would be in security domains on the side?
That's an excellent question. So, of course, the stepping stones has some generic rule of good applet implementation. Let me simplify it like that. That applies to applications that are belonging to the telecom profile, but applies also to applications that are present on the secure element or the embedded SIM, even if they are not part of telecom profiles like the Strongbox application, the SAM, the applications that are stored in the SAM. And let me also highlight that TCA, of course, the last year, there was this extreme interest around the eSIM and the interaction of application within the telecom profile, but the TCA visibility and scope, together with the Java Card stepping stones, is not limited to SIM and embedded SIM, but embraces also other kinds of connected devices, such as the secure element in mobile phones, where is a typical place where you typically find the Strongbox application itself. So for sure, we focused in our presentation on the stepping stones for that, but in general, this concept of interoperability and security reliancy of the Java Card goes even beyond the content of the telecom profile. It goes to the applications that are loaded on the secure element, like the Strongbox, like applications that are managed by the SAM, like payment services that maybe are controlled by the OEM and not by the telecom operators, and so on.
Okay. And there's a question on the chat about sometimes these are guidelines that and best practices and checklists to follow, but sometimes there are malicious CAD files, and the question is: there are attacks published where attackers were successful in loading and installing malicious CAD files on embedded SIM. Is there a guideline for embedded SIM operating system to implement some set of countermeasures against malicious applets?
Okay, very good question. So, of course, the guidelines of the embedded SIM that prevent from downloading on malicious profiles are coming from GSMA, are coming from the protection profile, that is the basic security document, it's a product problem definition of security for the common criteria certification for the ESA certification. And GSMA is continuously maintaining those evolution, and TCA members are contributing to that. The stepping stones aims more to develop applications that will be as secure as they can be. But of course, it's not that we are saying, okay, the job of security is on the application side. The job of security is on our side, on the eSIM platform side, and we have plenty of regulations and rules to respect, and security certifications to verify that. Nevertheless, like in no security, the weakest, the weakest link is the weakness of the chain. So that's why in this document we present rules that apply actually to application developers. Hello?
Looks like we may have lost Sean Daniel for a moment.
Okay.
Oh, sorry, I'm back. Okay, I was on mute.
No.
So the question: is there a plan for the TCA to issue an update to TCALoader? And the person that asked the question says, I understand some interoperability issues have been corrected for some embedded SIM vendors. I'm aware of a SCP-81 issue, but have not been published to the TCA website. When will this be done?
Yeah, yes, like every tool, we got our bugs. I mean, it's a normal part of the software, and this SCP-81 is a already known and fixed bug, and we are currently testing the new version of the loader. So, beginning of next year, it will be published. Thank you for this question.
Okay, great. And I think it's we overshoot of 2 minutes. There was a lot of interesting questions and very interesting presentation. And I think you can reach to Amedeo if you have further question on this. Thank you everybody for attending. There has been a recording of the presentation. You will be able to access the slides and the recording on the webinar series website or the YouTube channel of the Java Card Forum. Stay tuned. There's one other webinar pending on digital currency from Lars Suppel, GND. Normally it should be Thursday. If you are not registered, please register on the website. If you cannot do it on Thursday anyway, there will be also a recording and you will be able to access the recording. And once again, thank you, Amedeo. Very interesting presentation. And thank you, everybody, for attending. And have a nice day or evening for all of you. Goodbye.
Thank you. Thank you all. Thank you, Jonathan. Thank you all for your participation. Have a great day. Bye-bye.